Fungua milango Baba. Aha. Fungua milango iliyofungwa Baba. Fanya njia pasipo na njia. Fungua milango iliyofungwa Baba. Fanya njia pasipo na njia. Paulo na Sila pale gerezani walikuita, milango ikafunguka. Nami nakuita, fungua milango, fungua milango, wana wako wapitie. Ulifanya njia bahari ya Shamu, wana wa Israeli wakapita, mpasua bahari. Nakuita Baba, fanya njia watu wapitie. Fungua milango iliyofungwa Baba. Fanya njia pasipo na njia. Fungua milango iliyofungwa Baba. Fanya njia pasipo na njia.
Good morning, class. Good morning, and how are you? I'm fine, thank you. Now you remember yesterday we learned about weather measuring instruments. We learned about weather measuring instruments. And we also learned about the solar system, our solar system. Now today we want to cover something else, and this one now will be based on soil. Do you know what soil is?
Yes.
Do you know what soil is?
Yes.
Soil is the loose covering found on the surface of the earth. The particles of matter that is normally found on the surface of the earth. That one is soil. At times we can even call it earth. That's true.
Yes.
But now we shall be able to learn about how soil comes to be, how it is produced, how it happens on the surface of the earth. Understood?
Yes.
Now I'd like you to be very keen as we shall be going through this lesson. Be very attentive because I'd like you to get all the points that we shall be putting across. We shall also carry out a simple experiment on you and find out how soil behaves with water. How soil behaves with water. Now,
hello and welcome to this edition of science. In today's lesson, I want us to study more about what I'm holding in my hand. What am I holding in my hand? Can you see it? Very good. I am holding a piece of rock. I am holding a stone. From this stone, we can get several other pieces of stones. We can break it so that we get smaller pieces like this. We can break the smaller pieces so that we get at the smallest pieces like this. Can you see this? When we break this big one, we can get smaller pieces like this one. And if we continue breaking and breaking and breaking further, we shall get the finest or the smallest particles of this big piece of rock. So what do you get when you break a large piece of stone? Very good. You get small pieces. You get soil. So how is soil made? Soil is made by breaking down larger pieces of rock into the smallest and the finest and the smallest. Now, let me take you back to my rock. The large piece of stone can be broken to form these that I'm making. Yes, I'm breaking them. You can use a hard material to break a big one. It's hard. Or animals can step on them repeatedly and repeatedly until they break. Or when they are used for other purposes, like building and construction, they break into those smaller pieces. Or even when the rain falls and carries them, the small rocks keep hitting onto each other as they are carried away by the running water, and then they break into the smaller particles that later form soil. So how did we get the soil? We got soil by breaking the large piece of stone into smaller ones and later into the finest. So soil is made by breaking down rocks. You can have soil with broken down pieces of rock that are very rough. Or you can have another which are further broken from this rough one to become finer, and even the finest that even as you feel, you don't get any roughness. When we feel the texture of soil, we are able to identify the method that was used to break it or the type of soil. So one way of identifying a type of soil is by touching it. This is rough. This other one is smooth. And that depends on how far the rock is broken. The process of breaking the bigger rock into the smaller ones and finally into the smallest one that forms soil is called weathering. No sunlight, we
Now, what process is soil made from?
Animals can step on them repeatedly and repeatedly, and we got soil we are able to identify the method that was used to break it, or the home soil, is called weathering.
The process through which rocks are broken down into smaller particles until the particles are very, very small and fine. That process is called weathering. It is called weathering. So soil is made through a process of breaking down larger pieces of rocks into smaller pieces, and we call that process weathering. We call it weathering. As you can see, weathering is the process by which rocks are broken down into smaller particles. Understood?
Yes.
And we say that some rock particles will end up being rough, others will end up being average, others will end up being very fine and smooth. The roughness or the smoothness of the soil particles is what is referred to as texture. Can you say texture?
Texture.
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 Soil texture is the roughness or smoothness of the soil. How you feel the soil is. Understood? And weathering is the process of breaking down of the rocks into finer particles, which will end up being called soil eventually. Understood?
Yes.
Therefore, soil is formed by weathering. How else can we identify the different types of soils apart from touching them? We can identify different types of soil by planting crops onto them. There are some soils into which, when you plant a seed, the plant does not grow healthily, while in other soils, the plant grows healthily. The plants grow healthily in soils that are fine because they are able to retain water. So how do they retain water? With me are 3 samples of soil. This is one with very rough particles. This is another with particles that are not as rough as the first one. And this one has particles that are very, very soft. Very soft. This is rough.
Now, apart from feeding the soil, you have been asked, how else will you know that a soil is good or is of the cell of a particular type? We have to try and test out by growing crops. Understood? In some soils, the crops will perform very well and they will grow very healthy. In some soils, the crops will perform averagely well, and in some crops, the plants will perform dismally or very poorly. They will not be healthy. Understood? Now, apart from filling the soil, we can have samples. We have here a type of soil. Another type of soil is here. And another type of soil is here. Now, I'd like you to be very keen. We want to test them using the funnels and the collecting containers. They are all empty now. Understood? Now, for us to test them, we will pour some soil We'll pour some soil in these containers. But what will happen if we pour soil in this funnel and the opening is open? All the soil will go in here. So what do we need to do to stop soil from getting into this container? Yes, but we can use cotton wool. I have some cotton wool here. So we will split the cotton wool into equal amount of cotton wool for the 3 containers. I'll put one here. Another cotton wool here. And another batch here. Why am I putting cotton wool? Why am I putting cotton wool here? Who will tell us why? It is to stop soil from getting down. I measure equal amount of this type of soil. Are you paying attention? There we have it. I think this one will be able to do it. Okay, good. We have to make sure it is of the same amount. Soil A, I pour it here. Use the same measuring container for a second type of soil. The same amount. There we go. That is another type of soil here. Soil sample. You can have another sample here. And then finally, you get this one. Get another sample. Where is that one? Here. Third sample. This one is still left. The comparison. Now, after doing that, we want to test the ability of the soil to allow water to go down. Understood?
Yes.
So, we shall use this container to measure an amount of water up to maybe that level. And we pour it. Someone to help me? Can you empty this? Here. cups. For this was how much? This one here. For this one here. Now we want to measure the same equal amount of water. Which level? 1, 2, 3, isn't it?
Yes.
We pour here. 3. We shall pour it there. Up to number 3, 2, 3. Yeah. Up to number 3, 1, 2, and 3. There. The amount of water is the same, isn't it? In the 3 cups. So we realize that the size of the funnel are the same. The amount of cotton wool, the same. The amount of the soil, the same. Isn't it? Amount of water to be poured in these containers will also be the same. Understood?
Yes.
So I'll use 3 pupils. 1, 2, and 1 more to come from this side now. Good. We have 2 boys and 2 girls. Come in the middle. Now when I say start, you will pour your water in your container. You will do it this side. So when I say start, you will pour it when it is just there. Each one will pour 1. Understood? And we'll pour, and then we shall give them equal amount of time to find out which soil, after how many minutes, which soil will drain, will allow the most amount of water to go down. Understood?
Yes.
Maybe after 2 minutes or after 3 minutes. And then we shall even draw and record. So, what do you think will happen to the 3 soils? There are 3 types of soil. One with very rough particles, one with average particles, and one with very smooth particles. So, I say, we look at them first. Start. Before at the same time. Ukijaa unawacha unangoja. They have poured. You see? Which one is draining a lot and very fast? Are you seeing what is happening here?
Yes.
And this one, are you seeing?
Yes. Yes.
And this one? After finishing pouring all the water, we shall say, stop, to find out who still has water in the cup and who does not have water in the cup. You still have a lot of water. Okay. You still have water? Yes. So it means that there is a soil here which has refused to allow the water to pass through it very easily. But there is one here in which, are you seeing the amount of water?
Yes.
This soil had very big particles. It allows a lot of water to pass through it very fast. This one is average and produces very clear water. But this one has little water. The least water is here. It still has water up here. So, which soil do you think could be sand? Who is this? Brian? Diana? Benson. Who had sandy soil? Guys. Brian, do you agree with him? Clap for him. All this water has gone down and it is all collected down. All the water has passed. Then, which type of soil do you think our girl had? Long soil. And our friend, with very little soil, with very little water, the amount of water collected is very little. The other is average. This one is the most. Clay soil. Do you agree with him?
Yes.
Clap for them. Good. Sit down. Let us see what happens here also.
This is in between, while this is very, very fine. Now, which of these soils retains more water than the other? During the breaking down of this stone, the complete breakage did not occur in this, which appears rough. The particles are rough because during breaking down of the large particle, there was no complete breaking down. But this has fine particle because it was fully broken down. But let us see how each one of them can hold or retain equal amounts of water when passed through them. Take for instance, I have a beaker, a small container with markings 20, 40, 60, 80 cubic centimeters. I also have glasses, 3 of them for every sample of soil. Then I have a funnel into which I have put some soil, and at the bottom of it, of the funnel, is cotton wool so that the soil does not get into the container. Then down I have the collecting jar, a container that will help to collect water for me when it passes through the soil. I will want to put equal amounts of water, and therefore I have to measure how much water I am putting in every soil. I've measured 80 cubic centimeters. That is 80. I'll put 80 cubic centimeters into the glass, the first glass. Again, 80 cubic centimeters
The same amount of water
into the second glass, and 80 cubic centimeters into the third glass. Like I said, equal amount of water for equal amount of soil. Which of the 3 soils will allow water to pass through it, and how much water? With me is a pupil who will help me put the water in the soils. She will hold one glass. Get closer. Good. And then we shall put water at the same time. So we go. Good. We have done. Thank you very much, my pupil. In the first soil,
Wow.
what?
The first soil collects a lot of water very fast. Huh?
Yes.
Wow. All the water has gone through the soil. All the water. In the second soil, some of the water is still collected up in the funnel, while a little has gone down. But in the third soil, no water has passed through. Completely no water. I want to put the second 80 cubic centimeters of water into the 3 samples of soil. Again, there is no more water in this first soil. All the water has been drained down. There is little water still in the second funnel, but most of the water has been collected down. But in the third soil, not even a dot of water has gone down. All the water is still inside the funnel. The second 80 cubic centimeters of water, I'll put it in the first glass, 80 cubic milliliters, 80 cubic milliliters for the second soil, 80 cubic centimeters, and 80 cubic centimeters for the third soil. Yes. 80 cubic centimeters. I will call my pupil once more to help me put the water into the 3 soils. I will put into the first 2, she puts into the third one. Like I said, her soil has no water, all the water has gone down. My third soil has not taken even a drop into the collecting jar, and my second soil has little water in the funnel, as most of the water has been drained down. So we put it once more. Let's go.
What do you think will happen? What do you think will happen when it pours the second amount of water? Will you tell us? Will all the water drain through the funnel in all the containers? No. One container we think will hold a lot of water in the funnel. Another container might hold very little, and then the last container might hold even none in it. That's true.
Yes.
So the process through which soil allows water to go down through it is called soil drainage. Can we say soil drainage?
Soil drainage.
Soil drainage.
Soil drainage.
Soil drainage is the process or the ability of a soil to allow water to go down through it. Some soil allow water to pass through it very fast. Some soils allow water to pass through it, but not very fast. That's good.
I can't continue putting because my two panels are full, but we will continue putting hers. Thank you. Very good. Thank you very much. She managed to put all her second 80 milliliters into the first soil, and it has all gone down. Remember, it was the soil that was not completely broken with large particles. While I was not able to put in the third soil because the first 80 milliliters has not been drained. And remember again, it was the soil with the finest particles. So what do we learn from this? That the soil that is not completely broken with the largest particles allow all the water to pass through it. It doesn't retain, it drains all the water.
The soil with the largest particles allowed all the water to pass through it. It did not retain, it did not hold back water in the funnel. So, in our experiment here, we realized that when we touched this first soil, which allowed all the water to pass through it within a very short time, we realized that this soil had very big particles. The particles are largest. When we touch them, the particles feel very rough. The particles feel very rough in our hands. That one was sandy soil. Soil which is sandy. It has rough particles. It has a lot of air spaces. So water is able to pass through it at a very high rate, a very high speed. Understood? Understood?
Yes.
And when we look at this,
It drains all the water. While the soil that is completely broken, the soil whose rock particles are completely broken, allow little or completely no water, like in our case here, to pass through it. Until I was not able to empty the second 80 cubic centimeters into it, because the first one has not been passed through. In conclusion, therefore, we can all agree that the large rock particles give water enough space to pass through it so that most of the water is collected in the collecting jar, while the other two soils whose breakage is almost complete, like in my third case, all the water is still collected in the funnel. Therefore, the ability of water to pass through soil is determined by the size of the rock particles. So in the process of making soil, in the process of weathering, if breakage is not complete, then the soil will release all the water very deep into the soil, while when the breakage is complete, then the soil will not allow all the water to pass through it. Now, if I were to plant crops in these three types of soils, let's begin with the first one. Remember, plants require water. So if I planted in this first soil, which does not retain water, then my plants will die, because all the water will go down. So this soil is bad for farming. While if I planted my crops in this that retains water, my crops will grow very healthily, they will be prospering, I will get good harvest because my soil, my plants will have enough water. The soil is able to retain enough water. Again, remember that living things that live in the soil will not want to live in this soil because they won't get water. The soil loses all the water. So they will want to live inside the soil which holds water. Because these rock particles are not fully broken, they form sand. Therefore, we call this soil sandy soil. From the name, from the particles, these are sand, so we have sandy soil. Sandy soil does not hold water, it has the worst water holding capacity. While this other soil that retains almost all the water and does not allow it to pass through very quickly is called clay. In between is the soil that allows a little and retains a little and is called loam soil. In our lesson today, we have realized that it is from a large rock which, when broken, we get smaller pieces of stones which, when broken further, we are able to get the finer particles that form rocks. We are also able to identify that soils get their names depending on the size. The largest one, sandy, while the finest one, clay. The one at the center, which does not drain so much and does not hold so much, is called loam. Why do we study the ability of a soil to hold water? It is because the plants that grow in the soil need water. So if you plant a crop inside the soil that does not retain, your crop will die or will grow very well because they need water. So we need to plant in the soils that contain or retain water for the plants to grow healthy. Remember, plants need water before germination of a seed. A seed needs water to germinate into a new plant. Then after germination, the new plant needs water for photosynthesis. The new plant needs water for transportation. And the new plant needs water to live. Therefore, before a farmer plants his crops in the soil, he has to find out which soil will retain water for his crops. Now let me ask you a summary question. During our study, which or what did we say soil is formed from? Good. Soil is formed from a large rock that, if broken by any mechanism, gives the finest particles. Very good. How many types of soil did we come up with?
How many types of soil? Yes. Three. Correct.
Good. We came up with 3 different types of soil. The one with the largest particles we call sandy. The second one with medium particles we call loam. And the third one we call clay. Which soil retained the most amount of water?
Which soil retain held back, remained in the funnel, the most amount of water.
Good. Clay soil
Clay
retains
soil,
the
good.
most
Now,
amount of water. Why? Because it has the finest particles. And sandy soil, we said, or we saw, takes down all the water, and so is the worst for agriculture. On that note, we come to the end of our lesson about soil. Until next time, bye-bye.
Good. Now, how is
Hello and welcome. Yes, another session of science. In today's edition, we are going to start.
now we learned something to do with soil, isn't it?
Yes.
Now, when you are learning about soil, you realize that soil is made up of particles got from rocks. The rocks are broken down into smaller particles until they are fine. There are some soils which have rough particles. Some soils have very fine, very smooth particles. Other soils have average particles. Understood? The soil with very rough particles, which are very large, have a lot of air spaces. And when water is poured onto them, the water drains. To drain is to go down. To pass through it, going down. That one is called drainage. It is called drainage. And because the drainage is taking place in the soil, then we shall call it soil drainage. Understood? At the same time, some soils will not allow a lot of water to pass through it, and it will hold back the water. So when it holds back the water, we say it is retaining the water in the funnel. When it retains the water in the funnel, we call it water retention. Can you say water retention?
Water retention.
To retain is to hold back. To retain is to
Hold back.
not to allow something to go out or through, to retain. So the soil with the finest particles will hold back the most amount of water in the funnel. It will drain the least amount of water into the collecting jar. Understood? So because it holds back, it retains a lot of water in the funnel without allowing it to drain into the collecting jar, we call it it has the largest soil particles with a lot of air spaces. We call this soil sandy soil. We did the experiment and we realized that in sandy soil, here, all the water was able to go down, isn't it?
Yes.
Within a very short time. Time. All the water had gone down. But when we poured water in the second container, some water was retained, some amount of water was retained, and an average amount went down. And that's good. So this container had some water retained. After 3 minutes, some water was retained here, and some water had gone down. It was average. But the last container, within the first 3 minutes, most of the water was still in the funnel on top of the soil, and very little amount of water had gone down. So the one which had a lot of water remaining in the funnel within the first 3 minutes, this soil had the finest soil particles with very few air spaces, so it retained a lot of water up and drained the least amount of water going down. This soil is called clay. Can you say clay?
Clay.
Clay. The average one was called loam. Can we say loam?
Loam.
And the one which drained the most, all the water almost immediately is called
Sand.
So which soil is good for crops? The one which allows all the water to pass through it, or the one which holds all the water on top and does not allow water to reach the roots, or the one which is average? Raise your hand, yes? Loam soil is the best for growing crops. I think with that we end today's lesson. Have a good day.
Fungua milango Baba. Aha. Fungua milango iliyofungwa Baba. Fanya njia pasipo na njia. Fungua milango iliyofungwa Baba. Fanya njia pasipo na njia. Paulo na Sila pale gerezani walikuita, milango ikafunguka. Nami nakuita, fungua milango, fungua milango, wana wako wapitie. Ulifanya njia bahari ya Shamu, wana wa Israeli wakapita, mpasua bahari na kuita Baba. Fanya njia watu wapitie. Fungua milango iliyofungwa Baba. Fanya njia pasipo na njia. Fungua milango iliyofungwa Baba. Fanya njia pasipo na